Good morning, everybody. November 2nd, second day of deer season, and this is math review. November 3rd, scratch that out, third day of deer season, this is math review. Mean divisions.
Deviations. Mean deviation. Thank you for that wonderful introduction, Martin. The first 20 seconds of my videos are filled with your rambling. It's perfect. Okay, I told you that we were going to get into something last class when we talked about your review for old things, old statistics. You did mean, median, and mode, and you looked at range. And range was the only way that you had to measure dispersion, or how spread out your data was. And it's a pretty, big picture look at how spread out your data is, because mean deviation is a new way to do it. It's a little bit better way. Range just takes your highest and your lowest numbers, subtracts them, and says, okay, look, your highest and lowest numbers are separated by 20 numbers. Mean deviation is a little bit more complicated to calculate, but it actually gives us a much better picture. So mean deviation, it measures dispersion. Okay, or the other way to look at it, this is actually what mean deviation is. How far away from the mean so from the average is your data. Okay, so like I said, before we only had range. So before, we used range to look at dispersion. So range was just high value minus low value. Okay, so the formula for mean deviation, there's two of them. Okay, choose the pen. So mean deviation is equal to, alright, the first one is just written in letters. So it's sum of deviations from the mean divided by total number of values. So mean deviation equals sum of deviations from the mean divided by total number of values. Okay, that's the formula written out in words. And actually I think that's the most useful one. I don't know, people disagree with me sometimes, and that's okay. Because I'm going to show you how to calculate mean deviation, and you actually just use a table. And if you lay it out the way I do it, it's a pretty straightforward formula to do. The next one is the mathematical formula. It has a bunch of math symbols, so that's the one I'm going to show you now. All right. But I think that for us, the one with the words is probably easier. Okay, so that's an odd looking E shape. Okay, this here is an odd looking E shape. All right, this means sum of. In math, if you ever see this in a math formula, it means sum of. Okay, so it means you're going to add up. These vertical lines here are absolute value marks. And this might actually be the first time you've seen absolute value marks, but they're pretty straightforward. Absolute value just means no matter what number is inside of those two lines, you're going to take the positive answer. So if you had something like this, right, if you had something like absolute value of -9, it equals +9. If you have absolute value of 3, it just equals 3. So whatever your number is, whatever you happen to get in here, okay, when you subtract these two things, if it's a positive number, then you just use the positive number. If it's a negative number, you just put in the positive number for your solution. Okay, n is your total number of values. So this formula right here and this formula right here are exactly the same thing. On your memory aid, honestly for this, your best tool is mean deviation, a little definition of it, an example showing you how to calculate it. The formulas aren't, like, unlike some of the formulas, like distance between points and division point, those are formulas that are easy to use, just plug in your x's, you do it. This is more of a process than it is a true formula that you use. Okay, so I'm going to show you how we calculate it, but those are your two formulas. All right, so let's look at an example. So I have this example here. Here's a table of values, and I have written all of my x's. All right, and so this is what you'll do if you have a question. Even if the question is given to you and the numbers are written out in this list, you're going to make it a table. Okay, so the first thing you have is your x's, all of your x's, and your table is actually going to have a bunch of different things in it. So your first thing is your table is going to have your x's. Okay. And actually, we're going to call it xi just so it matches the
How are you feeling, sir?
book. I'm good, thank you.
Good, that's good.
Okay, so if you can copy down that table, and you're going to have the 4 columns in it. All right, so the first one is your xi's. So xi just meant all of your individual x values. So this would be, the reason we put xi is the I can change, right? This would be x1, this would be x2, x3, x4, x5, x6, x7, x8. You have 8 total numbers.
What's x line over it?
So, great question. So the x, we call it x bar, x with the line. That's the symbol in math for the mean. So that's your average, something that you know how to calculate. Okay? Xi minus x bar is pretty straightforward. You're just going to take this and subtract this. Put the answer there. And then this spot is for the absolute value. So if this one happened to come out, if here happened to come out as a negative number, you're going to write it as a positive number. I'm doing 4 columns. When you do this yourself, you may forget this column. You may leave this one out. All right? If you go right from xi, x bar, absolute value, xi, x bar, that's fine with me. It just means you're going to have to do that extra step in your head before you write something down. But this will show you the 4 possible things. All right? The first thing we need to fill out in our table is what is x bar. Okay? We need to figure out what the mean is. So let's calculate that. All right? Mean equals, we've got to add up all of our numbers. So 1 plus 4 plus 5 plus 6 plus 8 plus 8 plus 9 plus 11, all divided by 8 because there's 8 numbers. All right, and if we do this calculation, we're going to get that our mean is 6.5. Okay, and so 6.5 is what goes into my table here, and really 6.5 goes in each one of these spots because the mean doesn't change. So if you want to write it once and then just put an arrow down showing that your mean is all the way down here, that's fine by me. All right. So 6.5 is my average, is the same thing all the way down. So now we have to do our subtraction. Okay.
I did this.
So we're going to go, it's perfect. So we're going to do this. We're going to go 1 minus 6.5. That gives me negative 5.5. I'm going to go 4 minus 6.5. Gives me negative 2.5. Alright, and we're going to do that for the whole table. So 5 minus 6.5, negative 1.5. 6 minus 6.5, negative 0.5. 8 minus 6.5 is positive 1.5. Got another 8, so another positive 1.5. Got 9, so it's 2.5. And 11, so 4.5. Okay.
What was 5?
Well, what is 5 minus 6.5?
6.
Negative 1.5.
Okay. Oh, sorry.
Okay. Now, the only difference between this column and this column is that anything that's negative here is just going to be written as a positive. So you can transfer your stuff over. So I have 5.5, 2.5, 1.5, 0.5,
Bold.
1.5, 1.5, 2.5, and 4.5. So now let's look back at our formula. It is the sum of deviations from the mean. Well, these here that we just figured out, these are all of our deviations from the mean. Actually, these are our deviations from the mean. These are the absolute values of our deviations from the mean. Or if we look at our fancy math symbol formula, sum of these. Well, look at that. That symbol and that symbol are the same. So now sum of means add them up. And so this is where you're going to see that it's really not so much a formula as it is a process that you solve with. Because now I'm just going to add up all of these numbers. So I'm going to add up all of these numbers. So if someone can grab a calculator for me and just do, alright, perfect. So we're going to go 5.5 plus 2.5 plus 1.5 plus 0.5 plus 1.5 plus 1.5 plus 2.5 plus 4.5 equals 20. Oops, need a pen. So if we add up all of our numbers here, add up all of these numbers, we get 20. And then again, we're going to look back at our formula. So we had to add up all of our deviations from the mean, and then we divide it by total number of values. So if we go back to down here, mean deviation is going to equal the sum of xi minus x bar. Give myself a little bit more room.
MD.
All divided by total number. So that's going to equal 20 divided by 8, which is going to equal 2.5. Okay, so your answer would be 2.5 for your mean deviation. On average, your points are 2.5 units away from your mean. That's pretty tightly gathered data. So that's the way mean deviation works. It's one of those things that
That means divide, right?
divide by, yeah. So 20 divided by 8 equals 2.5. Okay. We're going to use your Math 3000 textbooks to do a couple examples where you can try and do some of these calculations. And then I'm going to do some questions from the divisions book tomorrow, or next time I see you, which isn't for a while. Question, do you want it recorded or not?
No.
No? Okay.